NASA's plan is to build a base on the moon before sending humans to Mars so that the process of reaching Mars becomes shorter. Elon Musk, the founder of SpaceX, wants to win the race to Mars. In addition, European and Russian space agencies also talk about sending humans to Mars. But once we land on Mars, how will humans survive in its harsh atmosphere? Unlike Earth, Mars doesn't have enough oxygen, which is crucial for life. What is NASA's way of producing oxygen on Mars? And why won't the way the International Space Station produces oxygen work on Mars? Viewers, there are many reasons behind humans' desire to live on Mars. Sure, scientific exploration and curiosity about space play a big role, but there's also a bit of fear driving this wish. What if something catastrophic happens on Earth that wipes out our species? Like 6.5 billion years ago, the end of dinosaurs from our world. And it is also possible that we are seeing an example of climate change on Earth. This is probably the biggest reason that in the coming time, someone or the other will become Neil Armstrong of Mars. On the one hand, Elon Musk first intended to colonize Mars in 2026, but now a prediction of 2029 has been made on his part.
You've slightly put back the expected date to put the first human on Mars till 2029, I want to say.
Yeah, I mean, let's see. I mean, we have built a production system for Starship, so we're making a lot of ships and boosters.
On the other hand, NASA has also planned to land humans on Mars by 2030. But the question is not who will go to Mars first, the question is how will humans survive after going to Mars. Of course, many properties of Mars are similar to Earth. Like one day of Mars, which is also called Martian Day or Sol, its length is only 39 minutes longer than the day of Earth. There are different weather patterns there too. And just like Earth, Mars has ice caps at its poles. There is also an atmosphere on Earth, although thin on Mars, but there is an atmosphere. But one thing that is not enough for humans to live on Mars is oxygen. So how will this oxygen gas be made on Mars, not for a couple of people, but to keep an entire colony of Mars? When it comes to keeping humans alive in an extreme situation, the first thought comes to mind is the ISS. Today, 25 years have passed in the harsh conditions of space, and it has continued to provide oxygen and fresh water to humans. 4 to 5 astronauts are present at the International Space Station at all times, whose daily water requirement is at least 45 liters, i.e. 1,350 liters per month and 16,200 liters per year. In addition to this, 1,000 kilograms of oxygen gas is used annually on the ISS. And how oxygen is made in space 400 kilometers away from Earth. For this work, there are two systems in ISS. One is Water Reclamation System (WRS) and the other is Oxygen Generation System (IE). To understand why we can't put these two systems on Mars, we first have to know how this system works. Water Reclamation System collects water from human waste, i.e. urine, sweat and humidity, and then cleans it and makes it drinkable again. Locke said on one occasion that our coffee of tomorrow makes the coffee of the next day. The Water Recovery System (WRS) on the ISS purifies the water that's already there so it can be reused, saving about 98% of water from going to waste. Next to it is Oxygen Generation System. This system takes a little water from WRS and then passes it through a special process to make oxygen to breathe. We had studied this simple process in 5th class, which is called electrolysis. Electrical current is passed through water, which turns water into oxygen gas and hydrogen gas. Oxygen gas is used to breathe, but hydrogen is a very dangerous and inflammable gas which can burn the entire ISS in seconds and turn it into a fireball. This hydrogen gas is not wasted, but it is put in another system which is called subattier system. This system collects the waste carbon dioxide of astronauts present in ISS and mixes it with hydrogen gas, which turns it into water, methane gas, and a little bit of heating. The water is brought back into use. The heating is put into the heat management system. But the methane gas, which has a lot of importance on the Earth, is taken out of the ISS into space. Methane gas, which is also a kind of fuel. Energy can also be made from it and heat too. But it is wasted because it needs oxygen to burn, and oxygen is the most expensive on the ISS. If you look at the entire oxygen and water process of the ISS, then it depends on refueling missions. Because it is 98% efficient, but still there are losses and leakages in every system. That is why every 6 months or after a year, water and oxygen are brought from the ground and put into the ISS. These refueling missions are very costly, in which the cost of delivering just 1 liter of water to the ISS above 400 kilometers is more than $2,500. Therefore, making oxygen on Mars at a distance of 2.5 billion kilometers is not cost-effective in any way. For this, we will have to make a system that uses the resources on Mars and makes oxygen from it. In 2021, NASA's Perseverance rover was sent to Mars. A device was installed for this experiment, which has been named MOXIE, that is, Mars Oxygen In Situ Experiment. Because in the ISS, the source of water is refueling, but to find water on Mars, you will have to go to its polar caps, or then you have to drill a few feet down and take out the ice. This is why MOXIE uses carbon dioxide from the atmosphere of Mars to make oxygen. To put it simply, 95% of the atmosphere of Mars is carbon dioxide. MOXIE pumps carbon dioxide from the outside atmosphere and pressurizes it, and then puts it in an electrolyzer and heats it to a temperature of 800 degrees Celsius. This separates the oxygen gas from the carbon dioxide. This electrolyzer is made of gold because gold is an excellent heat conductor which protects the other parts of the Perseverance from heating. In this process, carbon dioxide produces not only oxygen gas but also carbon monoxide. The disadvantage of this is that if the carbon is completely separated in this process, it can also make a layer of carbon, as seen below the cooking pan. And this layer will not delay in damaging the Perseverance. This is why this process is performed very carefully. But how much oxygen does MOXIE produce at a time on Mars? In this process, MOXIE needs a lot of energy. This is why NASA sometimes runs it when energy is saved from the solar panel. So far, it has only produced 122 grams of oxygen, which can keep a person alive for only 3.5 hours. If more oxygen has to be produced on Mars through this system, a large version of MOXIE would be required for it and a large power plant to run it. And this is the biggest challenge so far. Now the thing to understand here is that MOXIE first compresses carbon dioxide with the help of a compressor and then heats it to 800 degrees Celsius. A lot of energy is required for both these processes. For the solution to this problem, scientists are working on a future technology in which the carbon dioxide molecule can be broken at a low temperature. Instead of heating carbon dioxide, we're going to create vibrations to separate oxygen molecules from it. Currently, this technology has been tested in the lab, but due to the high atmospheric pressure and temperature of the Earth, it is not possible to do this experiment on Earth. But the atmosphere of Mars is absolutely perfect for this work. Whatever the technology, our target is that we have to use such a thing on Mars to make oxygen that is present there. And the device that will make this oxygen, its dependency should not be on Earth. Because ISS is only 400 kilometers away from the Earth. If the oxygen generation system there fails, getting astronauts back to Earth isn't a huge deal. But if there is a problem with the oxygen generation machine after colonization on Mars, then there will be no option for refueling and it will not be so easy to go back to Earth. I hope you will like and share this video. Thank you very much for your loving comments. See you in the next great video.